Hello everyone, welcome back. Today we will talk about R square and R adjusted R square. So couple of videos we learned how to find the best fit line to our data using linear regression. So assume that we have, for example, this example, we have experience and salary, and we try to predict our salary based on our experience. So this is the formula. The predicted salary equal theta 0 plus theta 1 multiplied by experience. So, and we assume this is the best fit line to our data. This from this figure we see this is the best fit of our data to our the best line to our data. So, but we would like to have any metrics to measure the performance of our model and to measure is this, for example, this model is good or not. Could we apply this for the to predict unseen data or not? So for the regression we have mainly two metrics, R square and adjusted R square. We will have a look in this example. So R square it's explain the degree to which input variable explain the variation of our output. For example, in this example, the experience is try to explain the variation of our salary. And the R square it's the R square values is between 0 and 1. R square high value in it means better model. We will see this just make underline under this statement, so we will see this is correct or not. So for instance, how to find R square? We can find R square with this simple equation. It's equal sum of square of residual. It means our the error of the model. It means, for example, we have this salary and our model will try to predict a salary here, y hat. So in this for this formula we have y it's indicate to our salary. So yi it means y1, for example, from y1 this value minus what we already predicted plus square, then plus the next value. We'll see one example in the next slide. For instance, assume that we have this is the experience and here the salary, the real values, and we tried to build a model with the linear regression, and the model is predicted these values. So for example, if you have one year of experience, you will get this amount of money. If you have 2 years of experience, you will have this amount of money. I mean, predicted this amount of money. Now, here's the real value or the true values, actual values, and this is the predicted. So now we will compute the first term here, y1 minus y hat square to the power 2. So this means this value minus this, the actual value minus the predicted value square plus this value minus this one plus and etc. This is y minus y hat square. And here's the sum of these values. Now we need to have this one, y minus mean of the y. So here's our actual y. We have to find the mean values, sum divided by number of, in this example, sum of these values divided by 10 because we have 10 values. Now we will have this values, for example here, this value minus this square plus this the second value minus the mean value plus the third value minus the mean value and etc. So we will have this value, some values, and 1 minus this value divided by this, we will have 0.95, which is a good, it's a high value. So if you have a square, in this case we will see our model is is good. Our model is fit the data. That is the best fit to our data. But we have some problems with R-squared. So as with the increasing number of predictors, for example, here in the previous example, we have only one predictor, which is experience. So if we have n predictors, this means R-squared will not be decreased. So it keep going to increase to close to 1. But and also this lead to overfitting. So but how to handle this problem? We need a matrix that able to find to tell us that our model is good or not. So we can use adjusted R-squared. Adjusted R-squared, it's just the same of R-squared, the same formula here as you can see here, but it penalizes your some variables of your data. For instance, if we have, as you can see here, this is the equation to find adjusted R-squared, 1 minus R-squared multiplied by m minus 1, where m it's number of samples in our data set. For instance, if we apply this for this example, we have 10, and m minus key minus 1, and key it means number of features. In the previous example, we have only one feature. It's just only the predictor, not with the class label. So to find adjusted R-squared, we have to find R-squared, and you can see here this is the value of adjusted R-squared. So it's minimized. It's less than the R-squared. So this is the real value. This is the best value you can trust. So if you apply linear regression, you have to trust R-squared, not adjusted R-squared. Sorry, not R-squared. Adjusted R-squared tells you that how much your model fit your data. So for example, here's 90%. It's good. So and assume here we have this data set. It's a 50 startup companies. So let's just what does that features mean? What does that features mean? So assume that there's 50 companies, and for example, the first company spent this amount of money in research and development, and spent this amount of money for administration, this amount of money for marketing, and they got this amount of money as a profit. So assume that we already create our linear regression, multiple linear regression. If you have no idea about this, I have some videos and you can have a look on this. So now number of, let's say we have only this symbol of data, just 10 rows or 10 data, and number of features is 3. 1, 2, 3. This one is the class label, it's considered as a class label, it's not counted here. Now assume that we have the predicted value. Our system or our model is predicted the profit these values. For instance, if we have this and this, we have the predicted profit is this value. So now we have to compare the R-squared and adjusted R-squared. So this is, I think, with the previous equations, it's easy to find. So now as you can see here, R-squared it's 0.92, but adjusted R-squared is 0.881. So this means R-squared with increasing number of features, it will not be never, it's always increases. So adjusted R-squared, it means because it's penalized this sum of features here, so that's why we have a small value. But 88 for this example, just for this example, it's good. If you have 88.88 in your data or your system, you can trust your system. It's good. It's a good. But for your information, this R square and adjusted R square, it's for our training set. For example, we train the model on this one, and we test on the same data. So that's why we have high value. But in your case, you have to split your data into training and testing, and if you need also for the validation. And you try to find R square and adjust R square for the training, for the testing set. That's it. If you have any question, just drop a comment. Thanks, and see you again.